Hey, Algebra 2, it's Mr. Szybisty, and today we're going to do a little bit more work with graphing. Now, in A5, we talked about graphing absolute value. Remember, it looked like this. It had the absolute value bars, and when we graphed it, it looked like a V. Here in D1, we're going to talk about graphing things that are called parabolas, or sometimes called quadratics. The absolute value had absolute value bars. Our quadratics will look like this, y equals x squared. And instead of a V, they're going to have a parabola shape or a U-type shape. Just like before, anytime you saw absolute value bars, you knew that there was going to be a V. Sometimes we moved that V. The same thing is going to hold true for our quadratics. So if we see something like y equals x plus 3 squared plus 1, we know because of this squared, it's going to make a parabola shape. So that's something to write down in your notebooks right now. If you see absolute value, the shape is going to be a V. If you see a quadratic, if you see an x squared or the highest exponent is a squared, you know it's going to make a parabola, a U shape. Now I also want to share with you a few vocabulary words that we're going to use now whenever we talk about graphing: domain, range, increasing, and decreasing. Let's look at domain and range first. So the first one is the domain. The domain are the numbers we can put in. And usually, almost always, our answer is going to be all real numbers. And that's how we write all real numbers, just any number we can put it in. There are 3 times when there's an exception, though, and I'd like you to write this in your notebook right now. We are not going to see it until later, but let's put it in the 3 restrictions. The 3 times that you'll have a restriction on your domain, and the answer is not all real numbers, is if you see a square root, if you see a denominator that has an x in it, and the third one is if you see a logarithm. Today, though, we're not going to see these at all. So our answer, whenever we're asked domain, is going to be all real numbers. Finally, the range are the outputs. You remember that from middle school, that the range has to do with the outputs, or the y values. I'll show you how we find the range in just a little bit. We have to actually look at a graph in order to be able to determine that. But the range is going to have to do with the y-axis, the y values. The domain has to do with the x-axis, or the x values. The last thing I want to talk to you about is increasing and decreasing. Increasing means that you're going up, and decreasing means that your graph is going down. We're always going to break between the increasing and decreasing at high and low points. So here's a high point. I'm going to graph that, and I'm going to draw a little dotted line down. And here I'm going to do this and another little dotted line. This is what's going to break up increasing and decreasing. So this first part here, on the far left, I'm going up. This is increasing. So from here to here, I'm increasing. Also from here to here, I'm increasing as well. The only other part is right here in the middle, where I'm going down, where I am decreasing from here to here. So draw this graph. Make sure you draw in the lines to show how you break up. They're drawn through the high points and the low points, and then everything in the middle is either increasing or decreasing. We're going to use these facts when we analyze graphs in just a second. Here's our first example. We want to graph y equals negative absolute value x plus 3 plus 1. So I'm going to graph this. And I am remembering from before when I went through and I graphed this that the negative out front here means my v is going to open down. This means I'm going to go left 3, and the plus 1 means I'm going to go up 1. So I go left 3 and up 1. There's my vertex. And now I can draw in my absolute value. I know it's going to be a v. Now it's time for some other questions. Find the domain and range. Starting with the domain, I'll write a little d with a colon here to say that it's going to be the domain. I told you that the answer was going to be all real numbers unless you saw a square root, a denominator with an x, or a logarithm. We're not going to see that today. I know that the answer is going to be all real numbers. The range is going to be a little trickier. Let me show you how we can use the graph to figure out the range. First, it's important to note that this graph continues down all the way. That's what the arrows mean. To find the range, what we're going to do is we're going to put our pencil on the y-axis all the way at the bottom. That represents negative infinity, all the way at the bottom. All the way at the top, that's infinity. So I put my pencil on the y-axis and I go left and right. And notice that I'm going to hit the graph as it comes down there. So I know my first part is going to be negative infinity. Then I'll put a little less than. And I'm going to put a y because I'm talking about a y. Now I need to know my endpoint. Well, I keep looking and I'm going to keep hitting the graph as I move up. But there's going to be a height where I stop hitting the graph. And that's this height right here. If I go any higher than that, I'll no longer be touching the graph. So the range is from negative infinity to 1. Write this in your notes. We're going to use the y because when we talk about range, we're talking about y values. Domain in the future, we'll use an x because we're talking about x values. Now I need to figure out the intervals on which the graph is increasing and the intervals on which the graph is decreasing. So if we want to find out where the graph is increasing or decreasing, we have to find all the high points and the low points. Here's a high point right here, and I'm going to draw this. This is going to tell me where it breaks between increasing and decreasing. Notice that it's going through the point x equals negative 3. That's this x value right here. We're always going to concentrate on those x values. So taking a look at the first part here, I know from, now we're going left to right, so the left is going to be negative infinity, the right will be infinity. From negative infinity to negative 3, we are increasing. So I'll write INCR to mean increasing, and I'm increasing from negative infinity x until negative 3, until I get to this high point. Finally, I know I'm going to decrease right over here from negative 3 all the way to infinity. From negative 3 to infinity. When I'm talking increasing and decreasing, I'm going to use the x because everything refers back to x values. This x value right here and these right here on either end, the negative infinity and the infinity. To review real quick, at the top is infinity, at the bottom is negative infinity. That's when you're dealing with a y. When you're dealing with the x-axis, the left is negative infinity and the right is positive infinity. Now let's look at a parabola. All right, so here we are, example 2, y equals x squared. Now I know that this is going to be a parabola. It's going to have that U shape. And what you need to know about this is just like the v's are originally centered at the origin at 0, 0, so are the parabolas. So anytime I move a parabola, it's going to be from that 0, 0 position. So there I have my parabola. Y equals x squared looks like that. Find the domain and range. Domain, just like I told you before, no restrictions. This is all real numbers. Now for the range. Remember, what I do is I put my pencil on the y-axis because y has to do with range, and I go back and forth, and I notice that I'm not hitting the graph. As I go up, I continue looking. Oh, I start touching it at a height of 0. And now I need to look to see where I stopped. I continue to touch it forever. As far as I go up, I'll always be touching it, so the upper bound is infinity. Now I need to know increasing and decreasing. So remember from before, the last example, our goal is to locate the highest point or the lowest point and draw a dotted line in between them. What x value is that? That x value is x equals 0. I am decreasing over here. See, my u is coming down. Remember, when I'm dealing with the x-axis, all the way to the left is negative infinity, all the way to the right is positive infinity. So I am decreasing from negative infinity until I get to 0. And then, starting at that low point, now I start increasing again from 0 to infinity. So that's how this is going to look when you're dealing with a parabola. Now, let's go to the next example and see what happens when you move a parabola. Now I have to graph y equals x plus 3 squared plus 1. Just like with the absolute value, the same information is located in the same spot for my quadratic. All I know that's different between the two is because of the x squared that I have here, I'm going to have a U shape. So I know I will have to go left 3 and up 1. So I go left 3 and up 1. The outside is positive. There's no negative out front. Let me show you a plus there. So this is going to open up. My parabola will open up. And that's supposed to be a U. There's my U. All right, so now that I have this, now I can go and do domain and range. Domain, just like before, none of my restrictions apply here. That's going to be in a couple months. The domain is all real numbers. For the range, I put my pencil on the y-axis and I'm not hitting anywhere. Now as I go up, I start hitting at this height here, at a height of 1. And then I continue hitting it forever and ever and ever. Goes up to infinity. Remember, when you're dealing with the y-axis, this axis right here, the bottom is negative infinity and the top is going to be a positive infinity. Now it's time for increasing and decreasing. So let me write INCR and DECR. Increasing and decreasing. That has to do with the x-axis, that part right there. And I remember that all the way on the left is negative infinity. Over here is positive infinity. And I'm going to draw a line through the high or the low point. That happens to be x equals negative 3. Now, from the left to that point, I'm decreasing. I'm going down. Decreasing from negative infinity to negative 3. Notice how the notation doesn't change. It's the same every time. What changes, though, is what the x values are. And then increasing. From that low point, I'm increasing all the way out. And that continues all the way up and all the way over. That's from negative 3 to infinity. So there's all the information that you're going to need for this type of problem right now. Let's take a look at the next example. All right, now I need to graph this. This is also a quadratic because of this squared, so I know that the shape is going to be a U. And again, I'm looking for the same information that I've seen before. There's a negative out front, which means my U is going to open down like this. Minus 3 means I'm going to go right 3, plus 2 means up 2. So I can now graph this. I go right 3, up 2, and the graph is going to go down. Like that. Find the domain and range. The domain, just like before, there are no restrictions. The domain is all real numbers. And then the range, when I go through and I look for that, I put my pencil on the y-axis and I go left or right. Remember that this graph is going to continue down. So it's touching at negative infinity. A friendly reminder, negative infinity is at the bottom, positive infinity is at the top for the y's. So the range is from negative infinity, and then a sign like this, and then a y, and then another one. Where do I stop hitting? At what height? Right there, at a height of 2. I touch it for everything under 2. And so then there's the 2 right there. Now it's time for increasing and decreasing. I locate the highest point, and that's this point right here, and coming down, and I can identify that that is x equals 3. So now it's time for increasing and decreasing. Remember that this is negative infinity over here, and this is positive infinity over there when we're talking about the x-axis. So I'm increasing, and I'm going up here to here. So that's from negative infinity all the way to 3. So negative infinity to 3, I'm increasing, and then at the 3, now I start going down. So from 3 to infinity. And that's what I'm going to need for that one. Now it's time for a U-try. Today's U-try is to do a problem just like the 4 that we just did. Graph this. What shape is it going to be and why? That would be something to write down. What shape and why? Then how did it get moved? Remember, you're using your numbers out here to describe how your shape got moved. Then find the domain and range. Where is it increasing? Where is it decreasing? And your answer should look very, very similar to the answers that we've used before. Remember, in order to get full credit for watching this video, in your notes, you have to show me that you tried to answer this just like we answered the other ones. Bring your questions to class. We'll go over them, and I'll see you guys later. Congratulations on completing D1.